So I'm really glad that you are all here today this morning. What we're going to talk about is PacketFence. I've been working there for 2 years, and it's the first time we talk about PacketFence at such large event. We've mostly done stuff locally in Montreal, so I'm really glad to be able to talk to you about it, and I hope I'll share my excitement. So what we'll see today is what's network access control, really briefly. We'll talk about the secret sauce, so how we do stuff and how it works. We'll talk about why open source has been very helpful for us, the good and bad of the 2 years as a lead developer and some lessons learned and some ranting, and then the future of PacketFence, so a bullet list of stuff we want to look at in the future, and some community begging for help and stuff. So who am I? I'm Olivier Bilodeau, working as a system architect for Inverse since 2001, lead developer of PacketFence. I'm also teaching information security to undergraduate students in Montreal. I'm really into open source. I'm also a new father. I brought my baby here at DEFCON for the first, she's 7 months old, so it's been quite something, the airport and all that. I'm also enjoying CTFs a lot, so we're with the Amish security team doing CTF, and also the CISSP groupies, and we did the DEFCON qualification 2 years in a row with mitigated success. I'm developing Tom Droid, which is an Android application too, and so if you want to be interested in what I do and follow me, here are the social stuff links. This talk will implement you drink, me drink protocol. So if I say something stupid, you can interrupt me and force me to have a sip of a good beer. The beer I chosen was, I need to talk about it, was IPA, California IPA. It's really good. So I hope I'll make some mistakes. And there'll be some beers. I only have these left. But for the debriefing, so people that come to the debriefing after the talk and have good questions, you'll have a beer. All right, so network access control. This is like, you guys, this is the elevator pitch. Let's not focus on that. You guys are smart and you know what most of it means, so we'll go fast. Authentication. Basically, authentication is map username to IP addresses or MAC addresses. So the firewall doesn't discriminate between users and IP addresses, where NAC, it's the core focus is to be able to know this device is owned by this person, and it's really the binding of the two that is important for NAC. There's admission. Admission is allow, partially allow, or deny users, and there's control. So control here is to watch for unauthorized stuff, including outdated antivirus, patch level, someone scanning corporate servers, spreading malware, etc. So network access control has the goal to do all of that. There's the usual sales pitch stuff that you see, which involves a loop between detecting a device, isolating a device, notifying administrators about the states of these devices, and remediation, which is a key point that we'll talk about several times, which is how to help the user to remediate problems, including updating his systems and stuff. So basically, it's know who is using your network and making sure they behave. And we're not talking who an IP address. We're talking who a username. So it's really important, an authenticated username. So that's... With time, what NAC has become, well, remediation of users, as I just mentioned, guest management. So a lot of people want to handle guests, put them on the internet only, no access to the internal servers. So it started to do that. Asset and inventory management. So it's there, it saw the devices, and so it categorized them for you, and you see it. And also, it simplifies the access layer configuration. So the more technical people come to PacketFence because they are tired of doing per port configuration, manually switching VLANs to on ports. And so with a NAC, the VLAN management is all done in the server and more transparently, and it simplifies the access layer configuration. So the secret sauce. The technology, mostly Perl, some PHP. We're leveraging open source. The asterisk means that I'll be talking about it in the future. I did that a couple places, so this is the concept. And it's designed with high availability in mind, so everything we do, we always think about, we use active passive clusters, and so it's really a core focus because network access control, if it's down, no one accesses the network, which is really bad. So it's from the ground up thinking in clustering in mind. Key design decision that we've made with PacketFence, we're out of band, so this is the, by opposition to being inline, which means that it's really the infrastructure that takes a decision. We're not in the flow to the packet flow out to the network. So if the server fails, it most likely fail in a sane state. So it's really by opposition to inline where you see that there's a firewall doing the decisions and the packet goes through the NAC device. So we're out of band, so no packet is going through the server. We're doing edge enforcement, so this means that the decision for access are done the closest possible to the endpoint, the client computer. So there's no, it minimizes the attack surface by a lot. A client who has not been allowed in the network cannot scan servers and do anything. He's like, the switch decided that it couldn't get access, so really the edge kicked him out, if you want. We use no agent, so this is a lot of the proprietary NAC are using an agent-based system, and so we decided that it was error-prone and buggy, and in a world where there are several devices coming out all the time, we cannot cope with developing agents for all of these. So we decided let's not do that and focus on a web-based captive portal instead. And so that's what we do. Listen to everything is also a big thing that we wanted to do, is we see everything that's out there. So we sniff the ARP, we sniff the MAC address when there are security violations done by the switches. When we see IPs, DHCP, we gather all that information all the time. If a user hit the captive portal, we record the user agent. So we're really about identifying everything that's on your network. And a lot of people are amazed when they first plug PacketFence. Even if it's not doing enforcement, they will see a lot of devices that they weren't aware about. So out of band, how we do the out of band stuff is we rely on SNMP traps. This was the first technique that we developed in 2007, which was the first step that we forked out of the original PacketFence project, which was based only on the DHCP. So the SNMP traps, we have several implementation. One is for link up, link down events. One is for magnetification event with our, to my knowledge, a Cisco-specific trap. And then there's port security, which was at first Cisco-specific, but then got picked up by a lot of vendors. The port security, the advantage of port security is that you get the MAC address in the SNMP trap that gets sent to PacketFence, which means we don't need to go and spoil a thread going to the port and waiting to see the MAC address show up on the port, so it's really more performant. You have a comment?
If typos count, you have notification, not notification.
Oh yeah, that's right. Let's do it. That's good. Okay, so then we got radius-based technique that emerged, which is 802.1x or MAC authentication. We will talk about these in a sec. So we first implemented wireless MAC authentication because the customer demand was for wireless, to manage the wireless and the wired side with the same software, same solution, which has been great for us. Then we implemented wireless 802.1x, which is what most people know as WPA Enterprise. And then we implemented lately the wired MAC authentication and 802.1x pieces. So let's go into a little bit more detail. The SNMP trap enforcement works by event on the hardware that generates traps. We react to the trap. And then we use SNMP client to connect to the switch and then perform port authorization, so MAC address authorization on the port, and change VLAN if it's what is required to do the proper enforcement. So it's an asynchronous process if you want. For most of the vendor, it works really well. For some of them, we need to rely on Telnet or SSH because their SNMP interface is not good, which we don't really like. Yeah. So one of the advantage of the authorization and the edge enforcement by SNMP traps is that because of the asynchronous nature of the authentication is if, let's say, the system would fail in the last state that was established. So the port security trap is sent to PacketFence. PacketFence saw the trap, saw the MAC address, decided that it should have been in the VLAN 100. It will go and put the user in the VLAN 100. Then there will be no security notification that will be done by the switch because we authorize the MAC address on the port. So as long as not another device which has another MAC address which will generate a security violation and then the cycle again, then as long as you don't have new security events, the system will stay in the good state no matter if the PacketFence server is up or not, running or not. So it's really a great advantage for this technique. Now, digging into the radius-based approach, let's have a few reminders about the protocols related to that. Radius is a key value-based protocol for AAA. AAA stands for authentication. Oh man, how come I forgot? Authorization, thank you. I guess I'll drink again. Authorization and then audit. So it's a very infrastructure type. Accounting or audit, all right. I won't argue. You guys are right. Smarter than me. Twice. Okay. So it's an infrastructure protocol. There's nothing like the switch speaks with the server, and there's nothing that the client needs to implement. Let's not get into 802.1x so far. So if you look only at this piece, it's really infrastructure based. Now, let's build on top of Radius and see 802.1x then. What is it? Is Extensible Authentication Protocol over Radius. So EAP and all that nasty PEEP, MS-CHAP v2, and then encapsulation over encapsulation and stuff. So it's adding a lot of new components to the pure Radius that we just saw. So the actor in 802.1x are the supplicant, the authenticator, and the authentication server. I've never saw any authentication server besides Radius, but I'm pretty sure you can do it with Diameter. So it's options. The supplicant is actually the client, and you need something on the operating system to support 802.1x. So it's not as transparent as Mac authentication is. And the client-side software has been integrated in Windows, in Linux, in OS X for a couple versions now, so it's pretty stable. But we'll see problems with that later. And authentication, most people know it, authenticator, sorry, most people know it as the NAS, so the Network Access Server. All right. The protocol even allows you to send stuff to the client. So this is how WPA Enterprise is set up, is that it as part as the authorization and authentication, it will send the keys in this encrypted tunnel. This is all, if you see the little diagram, this is all pre-DHCP, so pre-IP, and this is why it's called port access control, port-based network access control. Mac authentication is simply taking a step back for 802.1x. When the device doesn't support it, we do a simple Radius authentication authorization with the Mac as the username of the in the Radius system. So it's really similar to the 802.1x, but there's no strong authentication. There's no end-to-end with the client, so it's more of the infrastructure is taking care of all the boilerplate, if you want. Also, in the new quote-unquote techniques related to Radius is Radius COA, which I'll talk about a bit later, which means change of authorization, which is RFC 3560. Anyway, you guys saw it. Which is, so the COA answers the problem of doing, because Radius is initiated by the switch and the client, the COA takes care of the server says to the switch, please rethink the security posture of this device. And so it's kind of adding a new asynchronous nature to the usually really synchronous nature of Radius. Never bring your friends to your talk. All right. So what do we do for the enforcement then? We accept most requests. And then based on that acceptance, we return the proper VLAN attribute on clients. When someone is not known to the system or is not authenticated, we return a registration VLAN, so a VLAN where we present the captive portal, or if the user should be in isolation stage, we return the isolation VLAN. And so that's how the magic does. So we do accept most requests. Otherwise, the user will not have network access, which is kind of defeats the purpose. We use FreeRadius to do the radius and .1x pieces, and it's great. Complicated to configure, but it's great. It works well. Now, what we added is a Perl module to the FreeRadius. FreeRadius has this RLM Perl facility, which allow us to use Perl code directly into the FreeRadius. It's very performant, and with that, we do a SOAP request to the PacketFence daemon, if you want, to the Apache of PacketFence. And the decision is taken server-side. So this allows for a nice architecture that I'll talk about later. Now, moving on to the captive portal. Various authentication mechanisms. So we support LDAP, AD, Radius, Kerberos, and guests. We use the portal to do the authentication. If a user did 802.1x, then the authentication already went to the AD server. So we don't need to present the captive portal. So it's there's a lot of options there, actually, if you want to automatically register devices and stuff. What does the captive portal do after someone's authenticated over HTTPS strongly is we redirect them to the internet. And we can also provide remediation information, which we'll see later. In order to reach the captive portal, on the VLANs where we present the captive portal, we provide the HTTP. And then in the HTTP, we provide the DNS server, and we do a DNS black hole. So any request will get the same answer, which is the PacketFence server. It's really simple, cheap technique that we do. And then with the first hit on the browser, we use mod rewrite to rewrite the URL. For example, google.com will be rewritten to pf.initech.com/captive portal, which allow us to have a valid certificate because we have a domain name there. So it's not like other solutions which are doing reverse proxying, which then you have SSL problems with that. So it's I'm kind of glad that we did that. So how do we do our voice over IP now? Our old technique, because we're kind of changing this right now, is we rely on CDP and the voice VLAN features of the switches, which is actually easy to attack if you want. So now what we do is we handle them as regular devices, and we try to automatically register them if the user wants that. But there's still the older technique, and CDP is so transparent that a lot of people prefer that, even if it's insecure. Over Radius, we do MAC authentication, and then your phone doesn't really matter. What matters more is your network device, so the switch in question. And with 802.1x, there are some vendor-specific attributes in Radius to control the behavior of the VoIP stuff, but we've never saw a lot of 802.1x capable phones, so it's really a tricky business, and we've done it over wireless and wired, but it's not. I think we only got it with Avaya so far, and there's not a lot of customer demand for it, and because there's not a lot of phone who does 802.1x, so it's getting there. Maybe I'll have another presentation on that.
How do you handle devices downstream from the phone?
The PC behind the phone, voice over IP. Yeah, this is exactly what I mean by voice over IP. Is that if it's only a phone, then I don't really care. I am handling it like a normal device. But if there's a PC behind, then There are problems with that, especially because we provide DHCP. You know, I'm seeing the time flying, and I really want a question about it in the debriefing, and I'll give you all the details. It is tricky business. When it's over radius-based technique, it's easier and it works better than when it's over SNMP-based techniques, because of the influence of changing the primary VLAN ID on the port and stuff like that. You really need to be careful and tag the proper voice VLAN and stuff. So yeah, I want to talk about this later. So, for the voice over IP, a little note to pen testers: most want auto registration of the phone. The phone doesn't have a browser, so you cannot ask your user to go on the phone and register it. So either they have a list of all the MAC addresses and they automatically register them, or they do it through several techniques, which is MAC vendor prefix. I saw that. I think the 3COM switches do that, which is really discutable, which is a really tricky, or I think insecure technique if you want. Others do it through CDP. We, PacketFence, do it a lot with DHCP fingerprints, which are something I talked about yesterday about the finger bank project, which is really rarely spoofed so far, but as more people will gain awareness that we're doing DHCP fingerprints, I'm pretty sure it will get spoofed, and then people will get access to the LAN by spoofing a DHCP fingerprint of a phone. And also, the phones that are 802.1x capable are doing MD5 authentication, which is a flawed EAP technique for 802.1x, so it's not great. And so the note is here: spoof any of these techniques and you'll get access to the voice VLAN, and then from that scan and try to pivot maybe if you can on the media server. So pen testers, you should really look into the voice VLAN stuff. So quarantine is the captive portal feature where we present remediation information to the user. Here's a screenshot of how it's done. Now, I made that up. It's not a real technique that we have. It's written here: you have been detected using Windows 95. Please install a decent operating system. Download OpenBSD. That will probably not work on a desktop computer, but I don't want to get a flame started. So the triggers we have for quarantine is operating system based on our DHCP fingerprint, browser, MAC vendor, Nessus, IDS, which is snort-based, which I'm going to talk about in the next slides. And so the captive portal provides instruction. It's really helpful to reduce help desk pressure when you implement NAC. And so we've been really enjoying doing stuff with that, and it's the customer who come up with the greatest stuff to do with the quarantines, and we really like that. So the policy checking and monitoring, how the Nessus side is client-side scanning upon authentication. It's, I say, somewhat limited, because if you don't provide a domain, for example, domain credential on the Nessus scanner, then you can only see the surface exposed on the client. So you can prevent them from running a web server, for instance, but you cannot do more. But if you do provide domain admin credentials, then you can, hit on the device and then list the patches and stuff like that. It's not free, and also the more tests you have, the longer it will take to authenticate, to authorize a device on the network. And it's something that a lot of people, it takes 2 minutes to do an Nessus scan on the client, it's too long, so let's forget about that. So it's been mixed love-hate relationship with our Nessus implementation. Then the snort piece is more, most of you guys know snort, I'm pretty sure. And so it's an intrusion detection system. You clone your traffic that is going to the internet, to the PacketFence server. You run a local snort instance there, and you enable the rules you're interested into, and the devices violating the rules will be isolated. It works really, really great, and we've been doing a lot of BitTorrent blocking, Skype blocking, malware detection, preventing users from nmapping the servers and stuff like that, and it's great. And with the quarantine captive portal, we are able to provide a couple of you can do BitTorrent 3 times. After that, you are completely locked out of the network. So each time we present you with the captive portal, but you have a button to re-enable your access to the network. So you can do stuff to annoy your users if you want, like allow them to re-enable their internet access 100 times or 1,000 times and see how long they will, you know, try again and try again and try again to do peer-to-peer before they are getting tired and just calling help desk. What's going on? No, we don't do that, and it's probably because we were never asked this. Come up over for a beer. So, again, being open source, we're really and running a business on open source, we're really tied to what's going on the. Here we go. Oh. I'm sorry. So yeah, we're always interested, and the syslog stuff, there are new switches that can send syslog events, and I saw the features and I never looked into it, but it would be something really interesting.
Why not log in or even connect to the database of another storage server that does see the traffic?
We do support that. We have a remote mode for Snort, which we use our own daemon, we tail the alert file, and then we do SOAP requests. So then you avoid crashing your whole PacketFence because there is a gigabit of traffic per second to analyze for Snort. But Snort, with his single-threaded approach, has been quite good because it cannot crush the rest of the system because it's only using one core, one thread. So it's still interesting, and we have a really big enterprise customer running Snort and PacketFence on the same server, and it's doing great. So how do we support network access? I see that I will run out of time. I need to move faster. Adding a new supported switch for the radius-based technique is really great. All we need to do is, because all the legwork is done by FreeRadius, all we say is we support wired .1x, and if the NAS port that is sent by the switch is the same as the EF index, there's nothing else to do. And then we implement deauthentication, which is, again, very standardized. There's the PAE reauthenticate SNMP MIB that works in like 99% of the cases. And so for us, adding new radius-based supported device is really easy. SNMP is more challenging because it's not standardized as much, especially regarding port security. A lot of the hardware do it per switch port VLAN, and some of them do it per switch port. And so because of that, there are different tricks that we need to do, especially with voice over IP again. So it's a love-hate relationship, and it's one of the things that brings us customers, and we work on supporting new hardware, and they pay us to do so. So it's been good for the business, but for your mental health, it's not that great. It's like there's nasty bugs in there. I'm going to talk about it a little later. But it's mostly read the switch documentation, try to configure it, figure out that there are mismatch between the documentation and how you actually configure it. And then you SNMP walk and you try to find the sexy stuff you're looking for, the MAC addresses, port security information. And then you do your SNMP set, and then when you got it working with SNMP set, then you port it into your Perl code, and then rinse, repeat, and you have a switch working with SNMP.
Are you working with all 3 versions of SNMP?
Yes, we are, but this is a NetSNMP library which encapsulates all of that. But we've got, I don't know if I don't want to name any names, but there are implementation of SNMP v3 which are really buggy, and it's not our fault, it's the switch's fault. And so sometimes, we face problems and we need to pull in other modules and stuff. And it's a love-hate relationship with SNMP v3. I really prefer when a customer has a management VLAN which is guaranteed to be isolated. And so I'm telling them, you know what, SNMP v2 is fine by me if you're sure that no one can sniff on your management VLAN. But again, it's all arguable. So the PacketFence Zen is the zero-effort NAC, which is a VMware appliance which we have version for the desktop suite and also the ESX stuff. So it's pre-installed, pre-configured, and people can really try PacketFence quickly with a VM instance. So just wanted to let that out. He's glad. I'm glad that you're glad. Okay, so open source for the win. What has been great for with doing open source for us is the vendor independence. A lot of the network access, our competitors, if you want, they really clue into a vendor, or they do not, and then do ARP poisoning or other inline techniques, which are, in my opinion, less secure. And so, because of being open source, we kind of, poke at the firmware and try to make it work. And when one wants a device implemented, we work on it. And a lot of the, let's say, mostly universities, they actually develop their own module and they send it to us. And then we support new hardware, and that's just been great. The proprietary pricing is questionable. There is per IP, per concurrent connection, per AP access point, per switch license fees. So it's really kind of odd, and for a lot of people migrating over to PacketFence, they tell me, like, we pay so much for our NAC solution, it just doesn't make any sense. And it's because they charge per IP, and people are using wireless, and every device that you have like 5 of them on yourself, and you just cost them 5 licenses because they all wanted to hook on the network. And so sometimes they really like, we need to move away from the proprietary stuff. Also because we can stay focused, and we build on top of Apache, Bind, DHCP, NetSNMP, FreeRadius, Snort, IP tables, Nessus, 70 plus CPAN modules that we pull in when you install PacketFence. So like, we're really into reuse, I guess. We use Linux, and it's been really great. So this is also an advantage because the stack is familiar. So you guys all know the tools, and when you really need to tweak the things, you can do it yourself. And when you need to troubleshoot, it's not dark arcane magic that you cannot understand or you need to call support for. It's stuff that you actually can see and that you can Google on Google. So it's great because, okay, I have this FreeRadius problem, I Google it, and then, oh, everyone has a similar or a twist different problem, and you can help troubleshoot yourself by doing that, which is not something we can say of the proprietary offerings. And so it's been also good. Security is not necessarily solely based on obscurity, sorry. So what I mean by that is that this is network access control. There are some things that we kind of lift the carpet and put the dust under the carpet because we are doing questionable things, because we want, the customer to be able to deploy easily, and, a NAC is better than no NAC, so we still need to have them. It all boils down to user friendliness versus security, and you guys all know about that. So other solutions can be all about obscurity, but since it's open source, people can look at it and say, hey, you guys are doing like funky stuff over there, and maybe you should not do that. And so it's an advantage because you can look at it, poke at it, and find problems. So what I've been learned and what have been we doing bad and doing good for the last 2 years, so let's go. Most NACs are easy to bypass. This is something I learned while working at Inverse because of network administration friendliness. So per port exceptions for printers, voice over IP, uplinks, you find them, you can leverage them. CDP is being enabled on access port, which is, in my opinion, a problem. Real DNS is exposed, so if your NAC solution is based on offering the internet DNS, there are a lot of tools to be able to tunnel TCP into DNS, so you can tunnel out. And because there is no authentication built into layer 2 or layer 3, if you're not doing 802.1x, everything can be hacked or spoofed. So you can change your IP address, you can change your MAC address, you can change your DHCP client to be able to spoof the fingerprints I was talking about earlier. You can spoof your user agent, and user agent spoofing has been known to get you out of Cisco's NAC profiler. anyway, they see if it's an iPod or iPhone or iPad user agent, then they let you through because they don't have any agents for this OS. And so because of that, again, it's because there's no authentication and you can spoof this stuff client side, and there's the trust, which is fake, then is easy to bypass. And so again, coming to MAC address spoofing, printers don't have browsers, so they will often be pre-registered into the NAC devices. And so printer is so easy to find the MAC address on a printer. You go there, do your physical pen test, you pop the printer on the side, you look at the MAC address, you put it on your Backtrack 5 client, and then boom, you're allowed in the printer VLAN, and you can start scanning the print servers, which are Windows, which are not patched, etc. So another thing I learned is that you can bypass 802.1x, but there's a talk actually right after this, which is focused only on that, a 2-hour talk on how to bypass NAC 802.1x. But let me still tell you what's the technique. So you put a hub between the victim and the switch. The goal is to prevent the port from going down. So if there is no link down, then the stack is not reset, because it's a port-based network access control, and once the access has been granted, there is no continuous monitoring of what you have been doing with the access. So you wait for the victim to successfully authenticate, because you put a hub in between. You spoof your MAC address with the victim's MAC, and then you plug into the hub, and bam, you bypassed 802.1x completely. This was I discovered this by kind of a mistake when I was working on 802.1x capable phones, and I kind of couldn't believe it, and I Googled it, and then I found on Wikipedia and on Microsoft there is an article from 2005 talking about this problem. But now the bad thing is that they're doing appliances like the Pony Express, which is doing 802.1x bypass. So it's really interesting to see that it's gaining traction after all that time. So the attack scenario is you have two things you can do. You keep the legitimate client connected, which is bad because you'll have duplicated MAC addresses on the same segment, but which is good because the client can re-authenticate if the switch asks to. Or you replace the legitimate client, which is bad because you won't pass a re-authentication request because you're not able to provide a strong authentication. But what is good about it is that you will not have network problems because there are no duplicated MAC on the segment. It works, and see the A Bridge Too Far talk by Skip, which is after this talk in track 1. And I'm pretty sure that because he's doing bridging, he'll be able to circumvent the problem I'm mentioning here, the attack scenario, because he'll be able to firewall in between, let the heap over LAN go through the client, but still intercept the good stuff that he's want to do in the man in the middle. Getting into 802.1x is tricky business. I'll just skip that. It's buggy. The support varies and stuff. Another thing, the 802.1x wired on Mac OS X is buggy. I haven't tried to reproduce it on in Lion, but it's definitely buggy. We opened a ticket with Apple, and they said send us a ton of logging, and we did, and we never hear back from them. But we'll revalidate again on 10.7. But still, the point is, it's just that we're always finding problems in every, pieces where we need to interact with, and it's not an easy game to be a network access control software. What I learned also is network vendor fragmentation. So VLAN assignment through SNMP is done in like, I don't know, maybe 25 different ways. There are port lists. They are really straight one assignment. So a lot of different weird stuff that you can see. Port security is named differently, implemented differently. SNMP access is inconsistent. If you go into the radius-based enforcement, then wired MAC authentication has many, many names. I think I have a few here. Where is it? So Cisco calls it MAC authentication bypass, or MAB. HP calls it MAC-based authentication. Nortel calls it NEAP, which is no EAP. Extreme Networks calls it net login. Juniper calls it MAC radius. So there's a lot of different stuff going on in that space, and it's not making anything easy for us. There are gray areas in .1x where you don't really have guarantees about what will go with the DHCP on the client, and thus the problems probably with the Mac OS X. The radius change of authorization is not supported everywhere, which makes it a little bit harder too. So really hard, but the situation on the wireless side is better. I guess they learned from the wired side of things, and they avoided a lot of mistakes. So Mac Authentication and 802.1x wireless is really great, and we've been implementing really more easily the APs and the controller. Usually, I don't know, like one day to figure out how it works and make it work, and another day to document for our network administration guide, and make additional tests to make sure that it will scale and everything. So 2 days, and we support a new controller brand, so which is pretty good. Learn network vendors firmware quality. So there are so many regressions, and we like get client, they update an iOS. Did I say iOS? They upgrade a switch firmware, and then boom, something that used to work before stops working now. And so it's really, really painful. Weird coincidences. I've saw the same exact bug implemented in like 4 different brands, and I couldn't believe it. I was like, it's the same bug, and it's an obscure bug. And so you see that there is probably a lot of, of people buying code out of other vendors and stuff, and a lot of reuse of the same code, which unfortunately I guess is handled very differently, because the bugs are fixed in one vendor but not the other one, but it's obviously the same bug. Also, something that happened with us is, oh, I think there's a bug in there, and the vendor says, oh right, it doesn't work using the command line interface, but it does work in the web GUI. But who manages hundreds of devices using a web GUI, aside from controllers, which do a pretty good job, but for switches, come on, this is really odd. And scale issues, I just wanted to hint on an issue I faced where the people were handling in the SNMP, they were handling the MAC addresses saw on the layer 2 in the same table as the MAC addresses secured on ports. So when you want to list the secure MAC address on the switch, if the layer 2 network is really large, then you start to SNMP walk tens of thousands of devices, and it makes the whole thing completely slower. So we often face problems like that, and that we just don't know what to do with that. And then we rant on the network vendor, and they say, hey, come on, it's not us. It's been working fine for most people. But then you ask them, do you have NAC implemented with one of the NAC providers? And they say, no, what's NAC? So it's a problem. I know some people aren't going to agree with this, but all vendors hold tight on their issue trackers. I'm talking network vendors again. Most, they hold tight on their firmware. So we have... the customer pays us to implement NAC on their switch, and we are having a hard time downloading their firmware. This is not normal. Like, we need to escalate and send a lot of email. Some of them even hold tight on their documentation. So we got a physical switch that they sent us, but we are having a hard time download a PDF to configure the said switch. It's really, really a problem, and can it just stop? Opening your documentation, opening your firmware has proven to be a good thing for, like, let's compare Visual Basic with PHP in the 95 days. PHP, all documentation was open, so it got picked up by search engines, and people who had problems had really, really easy way to find solution. But with the network control stuff, the network vendors, you Google and you get almost never good answers, and you get a lot of open-ended questions that are not answered. So please, come on, they should get wikis, and they should do it the open source way. It will make everyone's life easier. And right now, I think it's more penalizing their customer who paid for their hardware the way they are working right now. So I'm a little distressed by that. Okay. Okay, again, learn. Nobody does infrastructure authentication, which is a big security problem. Let's skip to that. Okay. The bad thing we do with PacketFence, first installation step, disable SC Linux. Yeah, that's right. We suck at SE Linux. We tried, we just couldn't figure it out. If someone wanted help, it would be really appreciated. We have 2 short release cycles for a core piece of infrastructure. We released 11 releases in the last year or so maybe. And so it's really fast for most people. We don't have Nmap integration. I saw Fyodor speak at DEFCON last year, and I really am into Nmap, but we still couldn't get help or time or customer mindshare to implement Nmap. So we've not done it, and I think it's bad. External code contribution are scarce. We're having a problem creating a good community, probably because it's not sexy doing network access control. It's really, enterprisey infrastructure stuff, which is really, really not attracting a lot of developers. And we're pretty much CentOS Rail for now, but we want to fix that. So what we've done that is good, we improved a lot on the last 2 years, the development process and the infrastructure. Fully automated smoke tests. We're packaging every night the software builds. There are new packages out, and you can hook on a Yum repository on the latest software. Our branches are stable, so we have a stable branch. Everything is public. There's no big code dumps like Android, where every commit is public and on the internet. So it's really a true open source project. All GPL, by the way, I don't think I have this anywhere in my slide. So it's all GPL-based license, the code. Is usability plus. We really work hard on simplifying the installation, the upgrades. If you've tried PacketFence 2 years ago, give it another try because it really, really changed a lot. We got enterprise new features, so you can have users right for people using the web admin. This way your help desk cannot screw up the whole system. We support routed environments out of the box. So we inject automatically static routes and do the DHCP config and all that stuff. So we've been deploying a lot in campus-based environment where you need to route between the buildings, and it works really, really well, and it was an appreciated feature. 64-bit support. We now have a fancy guest workflow support. We've been working on that branch for a year. And now we're about to merge it with the upcoming 3.0 release we're going to do. We improved performance in several occasions. I skipped that. Technology, we support web services to manage hardware. We've been doing also web services for the radius access control. So people could technically decouple the free radius. Let's say you keep your free radius on your per campus, and then you do SOAP requests, so web services requests to the PacketFence server. So you could have technically a distributed architecture, like 3-layer architecture, but based on radius. We also did PacketFence in the cloud on EC2. The only thing you need locally is an OpenVPN, and everything is tunneled. So this was more as a fun hacking project that we did. No one really wants to pay for that, we realized. Because it's too scary, to have network access in the cloud. Making inline and out-of-band work at the same time on the same server. This is really new, and we're releasing this with 3.0. So we'll be able to support old, ancient hardware at the same time as VLAN isolation and strong, good technique. This is really, I think, some interesting feature. How long do I have left? 2 minutes? Okay, I need to bypass that. I'm sorry. So we did a proxy bypass, client-side proxy bypass, really interesting. Read the slides if you want to see what I mean. JavaScript network access detection, we've worked on that too, which is kind of a hack because I'm trying to avoid the cross-domain origin policy stuff. And it's kind of neat, that's why I included it here, but let's skip that. So short term, we're going to do inline mode to support easier legacy network hardware, now in beta, so it's public already. We want to do radius accounting, bandwidth monitoring with the proper alarms for it, so we could be more a hotel-style network access control, I guess. We're looking into NAP and statement of health, client time checking, radius, change of authorization, which we haven't do yet, ACL and QoS assignment with radius. A lot of my colleagues have been working on that. We're now kind of unsure how we will present the interface to the user, but we've got the basic technology and technique working. It's just more of how we will present the feature to the user. We would like to support VPNs, so then we will be really covering every access control techniques that we know about. Debian Ubuntu support, of course. Longer term, we kind of hate the active-passive approach for doing high availability. We would prefer a simpler active-active clustering approach, so we're working on that. Nmap, OpenVAS integration, and making this stuff click next, 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 easy to install. We're making progress with this, with the 3.0 beta. We'll be able to, for the PacketFence Zen solution, it will be DHCP-based NAC. You plug in a trunk port, and it will mostly work for most people. So we're really making progress with that and trying to make it easier all the time. Research topics, so if people are really interested into more advanced stuff, we want to implement IFMap. We're looking at doing client-side agent, but we would like a multi-platform, like Python-based maybe approach and stuff. So yeah, that's pretty much it. We beg for help. We want everyone to use PacketFence if they can. Conclusion, I hope I demystified NAC for you guys. And you should give PacketFence a try if you manage the network, because I think you'll see value quite quickly. Thank you very much. See you in the briefing room.